In this video, we are going to evaluate integrals using the substitution method, also known as U-substitution. For our first example, we have the integral of x to the 1/5 sine of x to the 6 over 5 plus 5 dx. And we want to evaluate this integral using the substitution method. So the first thing I'm going to do, I am going to choose a value for u such that when I take its derivative and solve for dx, I will be able to cancel all x variables and we will have a function of u. Sometimes you have to guess the value of u and see which value works best. I'm going to choose u to be x to the 6 over 5 plus 5. So we're going to let u equal x to the 6 over 5 plus 5. Then du will equal to 6 over 5 x to the 6 over 5 minus 1 plus 0. Then we multiply by dx. So simplifying, we have that du is equal to 6 over 5 x to the 1 over 5 dx. And now I will solve for dx. So dx is equal to 5 over 6 x to the 1 over 5 du. And now I'm going to replace x to the 6 over 5 plus 5 with u, and I will replace dx with 5 over 6 times x to the 1/5 du. So we have the integral of x to the 1 over 5 sine of u and replacing dx with 5 over 6 x to the 1 over 5 du. And now I'm just going to bring 5 over 6 out, and I will cancel x to the 1 over 5 with x to the 1 over 5. So we have 5 over 6 integral of sine of u du. Now it is much easier to evaluate the integral, and notice that we have a function of u instead of a function of x. So evaluating the integral, we have 5 over 6 times negative cosine of u plus c. So the antiderivative of sine of u is negative cosine of u. Now we're going to replace what we have for the value of u and put it inside of the cosine function. And I will also bring out this negative sign. So we have negative 5 over 6 cosine of x to the 6 over 5 plus 5 plus c. Remember that we have to include plus c whenever we are working with indefinite integrals. If we were to have an integral that has a lower and upper limit, then you would not have to include plus c. For the next example, we have the integral of x squared over 5 minus x cubed all squared dx. And we are going to evaluate this integral using the substitution method. So the value that I will choose for you is 5 minus x cubed. So we're going to let u equal 5 minus x cubed. Then du is equal to 0 minus 3x squared dx. So du is equal to negative 3x squared dx. Solving for dx, we have dx is equal to 1 over negative 3x squared du. Now I'm just going to replace 5 minus x cubed with u, and I will replace dx with 1 over negative 3x squared du. So we have the integral of x squared over u squared times 1 over negative 3x squared du. And now I'm just going to bring out negative 1 over 3, and I will cancel x squared with x squared. So we have negative 1 over 3 integral of 1 over u squared du. And now, just to make evaluating the integral a little more easier, I'm just going to rewrite 1 over u squared as u to the negative 2. So we have negative 1 over 3 integral of u to the negative 2 du. Now we have eliminated all x variables, and we have obtained a function of u. So evaluating the integral, we have negative 1 over 3 times u to the negative 2 plus 1 over negative 2 plus 1 plus c. So that gives me negative 1 over 3 times u to the negative 1 over negative 1 plus c. And now I'm going to cancel the negatives because a negative times a negative is a positive. And I'm also going to rewrite u to the negative 1 as 1 over u. So I'm putting u back into the denominator. So we have 1 over 3 times 1 over u plus c. And now I'm just going to replace my value for u. So we have 1 divided by 3 times 5 minus x cubed plus c. And I'll just go ahead and include my equal sign. And I'll put it over here as well. Okay. For the last example, we have the integral of sine of 4t plus 12 all over cosine squared of 4t plus 12 dt. So I will choose u to be cosine of 4t plus 12. So we have u is equal to cosine of 4t plus 12. Then du will equal to negative sine of 4t plus 12 times the derivative of the inside, which is 4, and multiplied by dt. Solving for dt, we have dt is equal to negative 1 over 4 sine of 4t plus 12 du. Now applying our substitutions, we have the integral of sine of 4t plus 12 all over u squared times negative 1 over 4 sine of 4t plus 12 du. And now I'm just going to bring out the negative 1 over 4, and I will cancel sine of 4t plus 12 in the numerator with sine of 4t plus 12 in the denominator. So this is equal to negative 1 over 4 times the integral of 1 over u squared du. And rewriting the integrand, we have that this is equal to negative 1 over 4 times the integral of u to the negative 2 du. Now it is easy to evaluate the integral. So we have negative 1 over 4 times u to the negative 2 plus 1 over negative 2 plus 1 plus c, which gives us negative 1 over 4 times u to the negative 1 over negative 1 plus c. And canceling our negatives and rewriting u to the negative 1 as 1 over u, we have that this is equal to 1 over 4u plus c. And now we will plug back in our value for u. So we have that this is equal to 1 over 4 cosine of 4t plus 12 plus c. And that is how you evaluate integrals using the substitution method. Thank you for watching, and I will see you in the next video.